Hi, Professor. Welcome to Lab 1 of E176. My name is Chris, and this is I'm in Group 6, and this is our video on the ALU decoder. So for the code, we started by declaring the input and output, and then we use assign to assign the logic to the ALU control units. And the way we came up with this equation is from here. So I will just do the first line just as an example. For ALU control, so this is going to be 0 bit, first bit, and second bit. To get the second bit, get the equation for the second bit, because it is only active on this one, we look at the row. So for this one, we will put ALU OP first bit and then we can either include this or not. But if we include it, it's going to take more time and resources for our processors to process this. So we chose to ignore this. And we end it with, because we're looking at this row, we end it with function second bit, not function second bit, and function first bit. So that is essentially what we came up with, ALUOP1 and now function 3 second bit and function 3 first bit. And we do the same thing for the ALU control 1 and ALU control 2 to get these equations, and that's it. And then we go to the test bench. The test bench is also the same. We start by declaring all the inputs and outputs, and then we instantiate our device under test. And then we declare the clock, and we start by importing the vectors from this file. And then we instantiate, we reset all the values, and then we reset everything, and then we wait 22 time units, and then we set the reset to 0. After that, we generate a clock. Oh no, we already generated the clock. After that, on the positive edge of the clock, we wait 1 unit, and then we assign the values from the test vector, which we loaded up here, into our ALU. So the MSB will go to ALUOP, and the LSB of this vectors will go into the expected to check whether it matches with our output matches the expected output. And 1 second. Okay. And at the negative edge of the clock, if our ALU decoder is not on reset, and if the ALU control is not the same as the ALU control expected, we will display an error, and then we will add the error to 1, and then we move on to another vector, another line of vector, and then if the values loaded from the test vectors are all x, then we will print out that the test is completed. And this is our constraint. As you can see, we just use this. We just connected our ports to our pins, and this is the schematic that we got. And let me show you the, yes, close it. Oh, let me run the simulation again. Yes. Oh, oh, it's already loaded up here. So as you can see, this is what we got. So I'm gonna give you one example of this. and then I'm gonna explain it on our FPGA board, the rest of the cases. So I'm just gonna explain this case, 0, 1, if ALU first bit is 0 and zeroth bit is 1, we should get 0, 1, 1. So I'm gonna try to come up here and go 0 and 1 right here. If it is 0 and 1, we should get 0, 0, 1. And it is as expected. Yep, and that's it. I'm gonna go to the board. This is my final implementation. So as you can see, everything is switched off. And if I turn on the second bit right here, it should turn the last LED should be on. So I'm gonna turn on switch 5. Switch 5 right here and close this. The last LED is on, as you can see. And also I'm gonna try this 0, 1, 1. So I'm gonna set 1, 0 and then the last 2 bit. So I am going to set 1, 0 and the last 2 bit, and as you can see, it matches the requirement 0, 1, 1. I'm gonna turn this off again. I'm gonna test the next one, which is 1, 0, 1. So I'm gonna leave this as is, and I'm gonna change 0, 1, 0. So these two are not changing, and then 0, 1, 0. So it's gonna turn it on, and as you can see, it's 1, 0, 1. And if I change these two, it shouldn't matter. I changed it, it shouldn't matter, it didn't matter. And I'm gonna change this bit to 1, and it should be 0, 1, 1. So I am going to change this bit, and it becomes 0, 1, 1, as you can see. And then if I change this bit, it should become 0, 1, 0. I'm gonna turn on this bit. And now, this bit. And as you can see, 0, 1, 0. It is 0, 1, 0. Thanks.